Okay. So last homework we took things like this, systems of linear equations. We threw them into matrices. We did Gauss-Jordan elimination to end up at the reduced, or no, not reduced, row echelon form. There's another thing called reduced row echelon form. So let me grab. When it talks about row echelon form, it goes below it. But this is the row echelon form, and then the other thing we talk about reduced row. That's very similar. Except we get like zeros in all those other places, right? And hopefully you watch the video. If you watch the video, you'll know that, like, there is a way to do this stuff on a calculator, on some sort of technology. And I'm perfectly fine with you using technology on this section. Ms. Watson's the one that's giving this test, so you might want to double check with what Ms. Watson expects on her test. So I don't know what she expects. Any questions over the stuff that we did like yesterday over the Gauss-Jordan elimination?
Gaussian and Gauss-Jordan is different because Gauss-Jordan is the one that has the zeros over the ones.
So the Gauss-Jordan elimination is it's the math that you're doing to get to this thing. Okay. This is row echelon. The form itself is called reduced.
Okay, so Gaussian is where you don't necessarily have to have all the zeros and ones on the left side.
Yeah, so the Gaussian stuff and all this elimination is just the work that you're doing to get to this thing. And so that's like adding the rows, that's like multiplying the rows and adding the rows, that's like swapping the rows. All those steps that you're doing, that's the Gaussian elimination that they're talking about.
And then Gauss-Jordan is...
Oh, I don't know the difference between those two, to be honest. I would have to look it up myself.
Okay, yeah, because that's what kind of confused, because it says like use Gaussian elimination or Gauss-Jordan elimination, so it's just kind of hard to.
Yeah, off the top of my head, I personally would not know. If Miss Welch knows, is she around?
I am. I'm Googling it.
Like, I have no clue. It's something with the arithmetic process with the algebra that we're doing to get to this thing. I wouldn't focus on those words too much personally. And if you see those words, just know to put it in like this form. It's the work we're doing to put it in that form. Okay. And like I said, I don't know what Miss Watson is going to expect on her test. Like, I don't care. Like, personally, if it's my assignment and you're doing it for me, after 6.4a, you can use this up to 6.4b. You can use this in 6.5. You can use a calculator. I don't care personally. And even if like Miss Watson doesn't let you use a calculator, you're doing all this Gaussian elimination, and like I said, if you mess up at one step, every subsequent step is going to get messed up. So, like, even if she doesn't let you use a calculator to do these things, like, use a calculator to check yourself, right? I don't know why you wouldn't. If you have the technology, use it. Okay. So one other thing before we even jump into like today's lesson, the test, I am like almost graded with the test. I have like a few tests. I literally have like a handful of tests, I believe. I think there's 5 left that I still need to grade. I was grading through them. I was getting a good, what want to say? A good speed grading through them, a good pace. I got a good pace grading through them, and then like, I don't know what hit me. I had some kind of stomach bug or something. But it was one of those instances of like, do I carry on and possibly get sick, or do I take a nap and like be ready for class, sort of thing, right? um, and so I tried to make it to class today, so that we would actually have a class. So that was kind of my choice on that one, and I will hopefully get those tests graded. There's like 5 of them, like I said. I will hopefully get those tests graded and back to you by the end of the day, definitely by tomorrow's class, because we got to talk about them tomorrow. With that said, grades look like they're kind of all over the place, if I'm being honest at this point. I haven't looked at them. I haven't crunched them, so I don't know what the numbers are, the average or the median. Any questions on the class and the stuff that we're doing before we get into today's stuff?
How much of the test do you think would revolve around these row echelon forms and matrices and stuff, do you think?
So we're doing 3 sections in the matrices, right? So today we're gonna, like, yesterday we did the Gaussian elimination. Today we're doing more like, there's like a word problem, right? And then there's like the special cases, the no solutions, and the infinite many solutions. So I think like there would probably, if I were to guess, there's probably going to be at least one making you do the Gauss-Jordan. There's probably going to be like one of the special cases each, if I were to guess.
So like 3?
Oh, that's today's and tomorrow's, or yeah, today's and yesterday's. Tomorrow, or like not tomorrow, Monday, when we come back and do another lesson, we're going to do some operations with matrices. So we're going to be like adding, subtracting, multiplying by scalars. And so that will also be another set of problems. So there will be a few matrices problems because we're doing like 3 sections. And the other stuff is what? Systems of equations, I believe. I think this test is pretty much all systems of equations and matrices. Because the matrices are kind of the buildup of the, or the systems of equations are kind of the buildup to the matrix, right? We're doing all these systems of equations. And you can solve systems of equations without doing matrices. It's just like, you have to start recognizing certain patterns that are there, and you have to do like little tricks and gimmicks, and like it's not the easiest thing to do. Like plugging them into matrix is like, I don't know, as much as pain of the ass like Gauss-Jordan elimination is, like it is a godsend compared to the alternative, right? I don't know if it helps or hurts or motivates or demotivates, but like it is the better way to do things, right? Okay. Okay, so we have a few problems we got to get done today. Old stuff, old stuff. I think in the chat. Okay. I don't want to do this. 27 and 29. Let me swap my camera. We have a small class today. I'm not feeling groups today, to be honest. So 27 and 29, I want to give you a few minutes to work on them things. Yeah. What about 27? What sort of case is this? I guess we can talk about that. What's the telltale thing that you see here?
Well, 27.
Yeah.
Well, one thing that jumps out that I saw stood out was 0 = 0 at the bottom. So doesn't that mean it's infinite possibilities?
There are an infinite number of solutions for this thing. Exactly. Yep, yep.
Wait. So is this infinite or is this no solution?
So this one, 27, is infinite because it's 0 = 0, right?
Right. Okay.
So it is infinite, but it is not just anything and everything out there. So you do have to give me some sort of structure for this thing. And if I'm being honest, like I feel like I started out with probably like one of the hardest things in this section. I think this is probably like one of the hardest things in this section. So if this one's intimidating, don't let it like get to you, right?
Okay. So this is like a triple uh points um ordered pair.
Yeah, so you're looking for an ordered triple. Yep.
Okay. Well, I got. I mean, so Z is 0, I guess, right off the bat.
Yeah, I'll go over it and give the other people just a few minutes, I think, before I go.
Okay.
Ms. Welch has any advice for graphing things in 3 space? That is one of the trickiest things you can try to do. Is like try to graph something 3D on a 2D paper. It's not always the best.
Yeah, you gotta
No,
be good with
very.
art to do that. You gotta know how
It
to do
helps if you
drafting
put
and
your
stuff.
eyes cross-eyed.
Yeah. I wonder. Maybe this one. This page might be a good explanation, maybe. Okay. Maybe talking about this a little bit more before we actually go into the answer. So you said 0 equals 0, and then you said infinitely many, which I love. I love that. So I hope, like, you see that bottom line. I hope you can pull out the 0 equals 0. I hope my webcam doesn't freeze a whole lot like that. No, it's frozen. Okay, anyway.
Yeah, you cut out really badly.
Yeah, my internet connection's unstable, apparently.
Okay.
So hopefully that doesn't cut me off. If it is, we'll have to all log back in. I think we did that at once already a few fortnights ago, but okay. So I hope you see this thing 0 equals 0 on the bottom. I hope you can pull out the 0 equals 0. Now I'm disconnected. Now I'm connected. Now I'm back, hopefully. Am I back?
Yeah.
God, okay. Let's do this again. Hopefully you see the 0 equals 0. You think infinitely many. But it is not just anything and everything out there. It's not just all real numbers.
But I think your screen is paused.
No, it's lagging. I don't know what the deal is. Technology is working against me today. But it's not just anything and everything out there. And we did this when we had two lines, right? When we had two lines, there's so many ways that lines can intersect. One of the ways they can intersect is they can intersect over each other. And then we had that page. I don't have my notes. Yeah, I do. Let's see if I can bring it up. There's a page in our notes somewhere. This page, going back to this page, right? All the nice. Yeah. My camera's not working. Let's retry this. Start. Okay. I'm sure there's stick my camera, I guess. Okay. Let's restart. Here we go. It was this page, right? Let me bring it up. Like most of them we had a single sort of solution, right? We had that one point where everything is, all those three planes are connecting, right? And so you could give me a number for X, you could give me a number for Y, you could give me a number for Z. This was like inconsistent, no solutions. So if we're talking about planes, there's a few ways that planes never intersect, right? These three planes are never going to intersect. These three planes will never intersect all at one point. And so this was like parallel lines, right? We had parallel lines. Now we have things like parallel planes. And maybe even focus this a little bit, huh? There we go. That's a little more focused. And so that would give you no solution. If we're talking about infinitely many solutions, it looks like something like this. So it looks like a line in three space is what it should look like. And so if you think about infinitely many solutions, it is infinitely many, but it's not just anything and everything out there. So we have to talk about a line in three space. And so this is the sort of thing that I was talking about. This is probably one of the more difficult, or probably the most difficult concept in this section, if I'm being honest. We have to talk about a line in three space. Let's maybe like get a little. I feel like we need more of a thumb on like what's happening in 3 space though. Maybe. If I share this, I'm gonna share this. So I found this page. It does a pretty decent job of talking about points in 3 space and stuff, and they graph things a lot better than I could probably ever graph things. So they do their axis a little weird. They lay their x and y down, and then they do the z coming up out of it. So we have an x-axis that goes like this direction, a y-axis that goes this direction, and a z that goes completely up and down. And there's like some right-hand rules about how to do your axis and stuff. Okay. But 2, 3, 5. Hopefully we can kind of decipher what this means. This is my x is equal to 2. So I'm going 2 out in my x. I'm going 3 out in my y. And I'm going 5 up on my z. And this is a point in 3 space. So this is out here hovering in space. And so that's what a point in 3 space would look like. If we're talking about a line in 3 space, so like this line right here, it's coming up to this point, A, comma, B, comma, C. So if we want to talk about a line in 3 space, it's a bit difficult, but this is the sort of picture that maybe should be in your head. And let's solve this and then come back to this picture, and maybe I can explain like the solution a little bit better and like why we're doing the thing that we're doing. Okay. So we see this equation. If you see 0 equals 0, that is not a new thing. I mean, it is in the form of a matrix, but we've had that before, right? We know that that means infinitely many. And so hopefully you remember that. This, the other thing, polynomial term, or not, yeah. I still have some equations there, right? So I want to write my equations. So what are the equations that I can write from this matrix?
Y minus 2 equals 1.
So close. You're missing one little thing there.
Minus 2z.
Yeah, there should be a z attached to this too. That's one of them. What's the other one?
X plus 2y minus z equals.
Yep, that's it. Does everyone see where we're getting these two equations from? So I know we don't have too many examples of like the infinitely many. So it's kind of important y'all get this stuff down. I don't know how else to tell you. I'm like, I just graded tests, so I'm like, I hope they're listening about this. Okay. So the thing we want to do is we want to do a line in 3 space. When we're talking about 3 space, we are doing the order triple x, y, z. And so we see this one, it has x's. We see this one. We don't know anything about like what our z could be. And maybe it's silly. But z is always z. And so what we want to do is we want to write x in terms of z. We want to write y in terms of z. We want to keep z just z. Z is as Z does. Okay. So in general, it is usually easier to go sort of backwards, to start with Z equals Z and then do this equation. So going like from the bottom to the top on your matrix, it's usually easier to solve that way. So if I have X, Y, Z, this is good. This is the thing I want to solve for now. So how do I solve Y, Z? I'll give you a hint. It's probably got to be that equation because that's the only one that's got a, well, the other one's got Y in it. Never mind. I'm a liar. Well, how do we solve this thing for Y in terms of Z? So we're solving it for,
Rid of the 2z, put it on the other side.
yeah, we got to add that 2z over. So y equals, this 2z is going to become positive. Then we still have what, plus 1? So now I'm almost, well, I got part of my line. I don't know what my x is. My y, I know is a z does. And I use that one of the equations to solve for y. I have another equation here that x plus 5. And so I still want to solve for x in terms of z. And so if you did this on a calculator, you wouldn't have this problem. But they didn't do this on a calculator, or they did row echelon form instead of reduced row echelon form, right? If you have a calculator, you're going to go for the reduced guy, right? Like, I hope you go for the prettier looking guy. Don't lower your standards, right? Sorry. X plus 2y minus z equals 5, right? How do I solve this in terms of z? I have to do something here. I have to get rid of this y. I only want x's and z's in my equation. So how do I get rid of that y?
You do substitution.
Yeah, I do substitution. So I know y is equal to 2z plus 1. That's the thing I just figured out. So now I'm solving this thing. I'm solving this thing for x in terms of z.
I just simplify at that point.
Yeah, just simplify. So I hope like the first thing you see that jumps out is what? This distribution, right? So anytime you see some parentheses in there and you see a number on the outside, or like I hope it itches deep in your soul somewhere, like I gotta do some distribution. 2 times 2 will give you 4z. 2 times 1 will give you what? Plus 2 minus z is equal to 5. I think we got some common terms we can probably combine on one side. Usually after you do some distribution, there's some like terms. X, 4z minus 1z, cute little 1z, 3z plus 2 equals 5. Okay. So I want to solve for x. It's a single variable equation. I'm not going to spend too much time on this one, too much more time. But I have to what? Subtract 2 from each side. Let me grab paper. So x plus 3z is equal to 3. And then if I want to solve for x, I have to subtract my 3z. So x is a minus 3z plus 3. Okay. So this was the thing I had previously. So I have to put these together. So final step is to put this all into one ordered triple. Minus 3z plus 3. 2z plus 1 is my y. As z does. There he is. And so what is this? What does this represent? And I haven't been putting the words there, but we should really say for all real numbers z. I think the book says maybe something like that, right? We want this thing for all the real numbers z. So what is this thing producing? I kind of said it, but it's probably not super obvious. Like if
Well, it's like a line that
Yeah.
goes on for infinity.
yeah, it's a line in 3 space. It's going in space. Yeah. And that might be a little confusing, but this is like my x. So if I'm looking at like my relationship here, minus 3z plus 3, what sort of relationship does this look like? Just this minus 3z plus 3. If I had x equals, right, there it is. If you were to just graph an x and a z, what would that graph itself look like?
So the z-axis takes the x and y-axis and then pulls it into depth, correct?
Kind of. I think what you're saying is true. I'm not sure exactly.
Okay, so x equals width and y equals height, correct?
It might be.
I think I lost you again.
It might be, but there's just 3 different axes. I'm talking about just this formula, and I know it has
Oh, you
x's and z.
disconnected.
Can you not hear me? Am I here?
Yeah, I think you disconnected again.
Okay. Yeah, it says my internet connection's unstable for some reason. I don't know. I paid the Google Fiber bill, so I don't know why they're doing that. Okay. I know it says that x's and z's, right? But if this was y's and x's, what sort of relationship would that be? mx plus b. What sort of thing does that make?
So it's like a slope and a y-intercept.
Yeah, it's like a line, right? This is a line. This is in the formula of a line. So this is a line in x's and z's. And you can think of this as a line with y's and z's, right? And so going back sort of maybe to this picture, like this is how a line looks in 3 space, right? And maybe going back to that picture that I had, where is it? Share screen. Share screen. If we look at just the x and the z, well, this is really kind of bad one to do it on. If we look at just the y's and the z's, right? What sort of relationship, if we don't look at this x, so we're just looking at this plane going up and down, left and right, what sort of projection is that line in 3D going to make on this axis? Is that a weird question or no?
Okay, so if it's a negative slope, then it's going down from.
Yeah, that would be going down. This
intercept.
example would be going down. But I'm looking at like just this thing, right? If I think about the projection a line makes on these 2 axes, right? It's going to be another line. And if I think about the projection that it's going to make on just like the z and the x-axis over here, it's easy to see on the x and y-axis on this one because they have the line drawn for you. But in between any 2 of these axes, the projection itself is going to be a line, right? And if we put 2 lines together, it's going to create a line in 3D. And so, like, I don't know if you've seen like the orthogonal views or something like that. Is there that thing I can do for orthogonal view? Is there like a good example maybe right off the top? Like these sorts of things, right? Let's see. We're just looking at the line from like different perspectives, right? Is what I'm trying to say.
Mm-hmm.
There's like this sort of thing, this orthogonal view. We can look at the top, the left, right, side, front view. That's kind of like what we're doing to this line. But if it's a line in 3 space, it's going to look like a line when we look at like this projection and that projection, right? This is sort of what sort of what's happening there. So I know that was a lot of talking to talk about maybe like just the concept behind it. But this is a line in 3 space. That's what it looks like. In order to solve these things, we solve for x and y in terms of z, right? We look at this thing, we see it's infinitely many. Write your equations from there, right? And this is another thing. If you don't know how to do something, write what you know, show what you know, right? Write your equations from this thing. You should know how to write equations from a matrix. You should know how to write a matrix from equations, right? Even if you're like, this is confusing you, you should know how to do some of this stuff, right? You should know how to solve y in terms of z. You should know how to plug in things for a y so we don't have a y in there anymore. So substitution. You should know how to solve for a single variable. So I know like each one of these things is probably not difficult or the thing that's tripping you up in itself, but then we're like putting these things all together and it is quite a bit, right? I'm not gonna stand around and be like, this is easy. That's not gonna help you learn it, right? But it is doable, right? And if you practice it, you will get better at doing it. Are there any questions over this one, over how to get to, where am I at? Over how to get to this final thing? Okay, so I think this is probably one of the most difficult ones, but let's look at 29. So 29, what do you notice about 29?
The last row, 0 equals 4.
The last row says 0 equals 4. Oh, man. What does that mean?
Contradiction.
Yeah, it's a contradiction. What does it mean about my solution?
There's no solution.
So I don't know how to say this, but like, if I were taking this test, this is the one I would be praying for, right? It's like, oh man, I just got to circle that last line, say contradiction and no solution, and I'm done with this problem. A lot easier than that previous one, right? Okay. $47, $49. So I'm going to give you all a few minutes to work on those. And then we'll go over them. You can use technology if you want. But I'm going to give you all 5. Oh, man. I'm just thinking of I don't know if, what was that? I'm a big fan of like the Jordan Peele horror movies. He's doing a good job. Me saying me saying I'm gonna do. He took that Luna song that's called "I Got 5 on It" and made like a horror movie soundtrack out of it. It's kind of funny. Because like the original song's totally just like this party song, and he made like a creepy horror movie soundtrack with the same chord progression. It's great.
Hey, Matthew, I found a picture that might help on the infinite solutions. Let's see if I can upload it.
Can you screen share, or do I need to give you? I could probably make you co-host as well.
I saved it as a PDF. Let's see if it works. Let's see if you can open it. I just put it in the chat. You guys might already have it, but those equations are the equations of that line on that plane.
We need like one of those, like, what is Star Wars? What do they call them? Holodeck? Are they holodecks? What do they call them?
I don't know.
There's that game that they always played in Star Wars. It was a little thing. I don't know. It had the little hologram, or yeah, the projection.
Kind of like Beam Me Up, Scotty.
Yeah. Oh, holodeck was Star Trek. That's what it is. Like Abed's thing in Community. Star Wars one is something else. I can't remember it. I'll give you a hint on this one. If you're writing things as an ordered pair, you're probably doing things wrong in this section. There are 3 variables. There should be 3 numbers, right? Okay. I think it's time to maybe start going over these. Are y'all getting these? Are y'all doing them with technology, or y'all trying to do them by hand? I guess is my question.
I'm trying to do mine by hand.
Yeah, it's going to take a minute. I would try to do some technology of some sort. And I know, like, it's not, I don't know. Yeah. Typically, if we're in a semester where we can go to things physically, I could tell y'all just to check out a calculator for the test. But that's not really the situation with this thing now. Things have kind of turned, but there are other forms of technology you can use for your homework. You may not be able to use it on your test. But there's websites, if you do a Google, for Gauss-Jordan matrix or something.
Yeah, Desmos has a matrix calculator.
Yeah, see? Yes, I would definitely not like try to do these by hand for this assignment. Like, I'm not expecting you to. If you want to practice stuff, it's good practice maybe to do it by hand. Like, I'm not trying to knock it.
Yeah.
But
I just did it by hand so I know, like, so I can get it down and, like, just in case I don't have a calculator or something, just so I know what I'm doing.
yeah, definitely good practice. But I would definitely try to get a calculator, even if, like I said, even if Miss Watson's not going to let you, like, use it to show your work with the calculator or whatever, you can still check your solution. And these Gauss-Jordan ones, like, it's so many steps. I don't trust myself to do them without the calculator, right? I'm going to check my solution with the calculator if I do these. So, like, I definitely not expecting anything more out of you, right? So with that said, let's do them on a calculator. Okay. Can you guys see my screen, hopefully?
Yeah, we can see it.
All right. So if I do what? Second? I want to do second. I want to hit matrix. And I want to scroll over into the edit. I want to edit this 3x4 matrix. So what numbers am I putting in here?
Most, this is 3x3, right? Oh, I guess the other last one is the solutions. Okay.
Yes, you have to
Yeah.
put in another line for the solution. So that's a good
Okay.
thing to know. Yep. So this one is what? 1. What's the next one? 2.
2.
And then,
-1.
okay, so this is annoying. If you have a TI, you have to type in the negative instead of the minus. Even on this app, it's really annoying. You have to go hit the negative sign on the calculator. You can't type a negative on your keyboard for some reason. So. And this one is, I believe, what, 2?
2.
This one is 3. This one is
7.
7. This one is
0.
0. Okay, good. And this one is 5. And we have a 1, 1, 1, 3. 1, 1, 1,
Yep.
and a 3. And we want to not enter into this matrix anymore. So we have to second quit. It's like the blue pill and the red pill right here, all at once. There you go. So we have this thing, it's put into our calculator into the matrix spot. We want to do some calculations on it. So we go second matrix. We want to go over here to math. We want to scroll on over. That's cumulative sum, row echelon form, reduced row echelon form. And I think these things are actually like, well, are part of the Gauss-Jordan stuff. I think you can actually do Gauss-Jordan processes on your calculator. But do we want row echelon form or reduced row echelon form? I'm probably going to go with
Reduce.
the reduced one. It is prettier to pull out of, right? So reduced row echelon form, second matrix. Oh man, I've seen that for so many years and I'm still amazed they couldn't find a better abbreviation for that one. Sorry. Okay, so reduced row echelon form on matrix A. What does this tell me? Oh man. So this is the matrix it spits out. Let me copy this down right quick. 1, 2, 0, 0, 1, 0, 1. And it doesn't have the line in there when you do it in your calculator, right? But let's go back to my paper. If you're doing this in some sort of calculator or technology, this is the work I want to see. I want to see the matrix that you put in, and I want to see the matrix that it spit out. If you put anything less than that, you're going to get some points off. And so, I guess we can break it down. What equations is this giving me? So I'm going to go ahead and write
4.
4. What is 4?
X equals 4?
Yeah, x equals 4. This is giving me y equals
Negative
Negative
1.
1.
and z equals
0. So it was all done for you already.
pretty much.
But it won't always be like that, correct?
It won't always be like that. Sometimes it be like this, right?
Okay.
But most of the time, as long as it's not those special cases, most of the time you'll get like 3 numbers out of it. At least for our classwork, right? Maybe not in reality, but in the math class, we like you to solve things, right? So this is the normal sort of case is what I would say. And like these are sort of like special cases. And that's probably more like vocabulary dealing with our class than in reality, but okay. So that is my x, that's my y, that's my z. So it's practically solved. There's really one thing that I should do to give a solution. It should be an ordered triple, but it's like it's already in that order. Like you can just pick it right out of that matrix. Look how nice that is. So let's say some nice things about technology for a minute. Look at all this work we saved. And hopefully if we praise technology enough, it will quit working against us today. So praise technology.
The machine god. Have you heard of that?
Deus Ex Machina, isn't that something like that?
No. The
Isn't it
machine
something like
god
that?
is the Martians. The in Warhammer 40K. They worship a machine god. And they're like part human, they're like cyborgs. So they work in these giant foundries on Mars and they worship a machine god.
Yeah, I guess the singularity is approaching, ain't it? Okay, so this matrix. The next matrix. So what do I want to see? I want to see what you put in. So we need to put this thing as a matrix. So 3 minus 2 minus 2. So this one I think is a little more straightforward. 1, 2, 6. There's no zeros or anything kind of wonky in here. All right, hopefully. Okay, x, y, z minus 12. 8. So this is the matrix we should put into our calculator. So let me go back to share screen, share my TI Smart View, share. So I didn't do this in my notes, but look, we have all these things. We can put it in matrix A. I think I'm going to go with B on this one. There are all these sorts of things we can do. I'm putting this into matrix B. This is 3 minus 2. 3. Not minus 2, negative 2, because that's a big difference. Okay, negative 2, negative 2, negative 12. Can I? Oh, shoot. Negative 12. There we go. Make sure you hit all the buttons you want to hit before you hit enter. 1, 2, and 6, and 8, 4, negative 2, 4, and 8. So I believe I typed this thing in correctly. 1, 2, 6, 8, 8. I believe I typed it in correctly, but depending on your calculator, you may or may not be able to see all of your matrix at the same time. And so there's this little trick I do on my matrix on my calculator sometimes. If you hit second matrix and you bring it up, you can actually look at your whole matrix in like one screen. You can do a lot of stuff with matrices on this thing, right? It's pretty good. And we want to do the row reduced echelon form on our matrix B this time around. So we want to go to our second matrix. We want to do the math on it. We want to do row reduced echelon form. Second matrix. We want to do B. Oh man. Those are what? Fractions? Yeah, we could do that if we wanted. Those are probably even fractions or even decimals. But what if they weren't? What if I want to do fractions? Do you know how to do that on your calculator?
You mentioned it in the video, I think, but I don't
Yeah, it's
remember.
under math. It's under math, and it's like that first option right there. If you do math frac, it'll convert your answer to fractions. Look at that. 1, 0, 0, 0. Minus 26 over 5, minus 6, and 21. And let me stop my screen. Let me go back to this thing. There's the matrix I put into the calculator. There's the thing that it's spitting out at me. If I want to know the solution for this thing, I could go and say x equals y equals z equals. That's fine. But being honest, if it looks like this, personally, I don't care if you just jump to the solution from this matrix, right? And if I want to just jump to the solution, it looks like an ordered triple. What's the first thing I should write there?
Negative 26 over 5.
Yeah, I write my x, which is minus 26 over 5. I write my y, which is
Negative 6.
negative 6. And then the last thing is that 21 over 5. And there's your solution. Any questions on this?
So these with the perfect, where we don't really have to do any work afterwards, is reduced row echelon form, right?
Yes, that's reduced row echelon.
And then row echelon form is similar, but you have to do some more work, some substituting and stuff.
Yes, because there's still numbers up in here, right?
Okay, so that's the difference then.
Yep.
Okay.
So reduced row echelon form, and maybe like point this out, it like actually solves for the variable directly, right? Because everything else is 0. And so it like, yeah, reduced row echelon form is really preferable because it's like you're there, right? Reduced row echelon form, you have to do some back solving and some stuff, and it's not quite as pretty. So if you have technology, go with the reduced. I don't know how else to say it, right? But don't mess around with row echelon form if you have technology. Where are we at? 85 pumping water. So we need to come up with the matrix. We need to solve this matrix. So the first pump is twice as fast as the second pump. The first 2 pumps can empty the pool in 8 hours. Well, all 3 pumps can empty it in 6 hours. How long would it take each pump to empty the pool individually? Okay, so this is a word problem. So there is something you should do when you start a word problem.
Define variable.
Yeah, always define those variables. This one's a little tricky. So I think that maybe I should probably say this before people start digging into this a little too much. So if it says something like the first pump can empty the pool in 8 hours, or the first 2 pumps, whatever it says.
Wow, this is complicated.
Yeah, this one's a little bit, yeah, it's got a little bit to it. This is kind of like that rate thing, right? Again, right? If we do one pool. If we want to know the rate that is draining the pool, what is the rate that is draining the pool?
1/8.
It would be 1/8. So you have to be careful about what these rates are. I'll give you that much. So if you can just set this up with 3 equations, we'll talk about it. But I'm hoping you can get those 3 equations from the words. So let me put the words back up there. We got more after this, okay. Oh man, they tell us what the variables should be. I didn't even notice that. Whoops. Okay. So as far as defining your variables, they told us what x, y, z. I went with ABC on mine. So if we want to get the equations, first thing I see there, the first pump is twice as fast as the second pump. What does that look like as an equation?
Well, if the first 2 pumps emptied the pool in 8 hours, then you could go 8 equals, this is XYZ, right? Yeah.
Yeah, I'm just reading.
Sorry.
I'm just reading that first sentence. The first pump is twice as fast as the second pump. I want an equation from just that sentence.
Right. So it's like if the first pump is X, then the second pump is 2X. Oh, no, I'm sorry. The first pump is 2X. The second pump is X. That would at least make sense.
The first pump is twice as fast as the second pump. So I think you said probably like the right thing, but in the wrong order, I think maybe. This one should be faster, right?
Yes.
I wrote it out as x is equal to 2y.
Yeah, that's exactly what I did. That's another way to do it. So I think you're getting at the right idea, but I think you just said it backwards. But this is the way it should go, right? X equals 2y. You could do this one as y, and you could do this one as 2y if you wanted, right? So I'd go y and 2y would be the correct direction to do that in. But, ooh, and don't give out too much. Okay. So that's the first thing. I did it with A's and B's. I had to rewrite it as X's and Y's. But there we go. The next one says A and B working together, or sorry, the first and second pump working together can do a pull in 8 hours. So what does that equation look like? So if we put the first and second pump together, how are we putting them together? What's the operation?
I guess it would be x plus 2y equals 8.
Not 2y. It's just the one of the pumps. And it is x plus y equals, what is this number over here?
8.
It's going back to that thing. The time is 8. The rate is going to be what?
Z.
1/8.
1/8. And so this is that thing. If it takes 8 hours for one pull, they're working at a rate of one pull every 8 hours together. So this one, let me leave this one up here for a second, just so you can like swallow it a little bit. I think this one is probably the more difficult one to write. Do we understand why this is getting written the way it's getting written, though, hopefully? Silence is either a really good thing or a really bad thing when you're an instructor, and sometimes it's hard to tell. It's like either you're so lost you have no clue what to ask, or either you get it. It's one or the other. There's usually no middle ground on that one. So are we understanding like this thing with the 1/8, hopefully?
Yeah, that's where I went wrong on my first calculation. It makes more sense now.
Okay. Yeah, hopefully things will start working out. And then the last one says if we put them all three together, we're going to get what number?
1/6.
Yep, that's 1/6.
1/6.
And hopefully this makes sense too, right? If we add these together, this rate is going to be lower than this rate. If we said 8 and 6, we would say these two pumps working together have a higher rate than these three pumps working together. That wouldn't make a whole lot of sense, right? This one, yeah, it's a bit tricky. It made me think about it for a minute. But we're almost there. Not quite there.
The heck?
Is there a question?
Yes.
What's up?
Okay, I'm still kind of confused. I didn't know what to like. I'm just confused on like the 1/8 and the 1/6 and all that. Like,
Okay, so this is, think about it. If I'm going so many miles per hour for so many hours, this is the distance I'm going to do. But instead of distance, think about it as a work of draining one pool, right? And so if we can drain one pool, 8 hours, then what we're doing is we're going to have to divide by 8 here. But the rate that we're working at is one pool for every 8 hours, or 1/8 of a pull per hour is another way to look at this, right?
mm-hmm.
Okay. So that's where that 1/8 is coming from. Is that making a little more sense?
Yes.
So we want the rate. We don't want the pull or the distance or the work or whatever the heck you want to call this. We don't want this, and we don't want the time. So I think it's like it's really tempting to just put the time on this thing, right? X plus y equals 8. It sounds like that, and I will give you that. Like, it completely kind of sounds like that's maybe where you should go. But they're not asking for the time; they're asking for the rate. So we have to do a little bit more thinking about what a rate is. And then if you're working together, you're adding your rate. So that's another thing that like you might have to get in your mind, right? When we're working together, the rates are being added. So that's a little weird. But it is the relationship there. These, I think they're almost ready to put into a matrix, right? What about this thing? Can I plug this into a matrix?
If you make the other one 0, and
Yeah.
if you move over the 2y, you subtract 2y from both sides. And make that 0. Yeah.
Exactly. So that's exactly what you want to do. You want to put these things in standard form. You want to put all your variables to the left, all your constants to the right. If it's not in that form, you're going to have to convert it to that form, right? So we have 3 equations. We have 3 unknowns. So what I'm going to do is I'm going to plug that thing into a matrix. So 1 minus 2, 0. 0 is that first line. There are no z's here. So going again, if there's no z's, we put a 0 there. Here we have a 1x, we have a 1y, we have no z's. And this is going to give me 1/8. I have 1, 1, 1. And that's going to give me 1/6. All right. All right, so I'm going to do this on the calculator right quick. So 1 minus 2, 0, 0, 1, 1, 0. Let's see what I get. 1/8, 1, 1, 1, and 1/6. Yeesh. Okay. So definitely going to have to hit the frac button. But this is what I'm getting for my solution. So, going back over this, I got 1/12, 1/24, 1/24. Can I just start writing some sentences, or am I going to mess people up? Pump 1 pumps. How much does pump 1 pump?
1/12 of a pool per hour.
Yep, 1/12 pools per hour. Pool per hour. Pump 2 and pump 3 are both what? 1/24 of a pump per hour? Okay, we got this. You're on a test. Now what are you going to do?
It's already solved for all the variables.
Yep. You got your solution. And like I'm trying to hint, you're at a test. You're not just doing this for homework, for practice. You want to make sure you got it correct. What can you do?
Plug in the numbers.
Yes. So 1/12 plus 1/24 plus 1/24, will that give you 1/6?
I don't know. I have to check.
Yeah, but you can do it, right?
Mm-hmm.
Yep. So we can always check. If you have a calculator, yeah, you can always check real quick, right? That one looks like it works out. So we can always check these things, right? 1/24 plus 1/12, that should give you 1/8, I believe. So we should be able to check these things. Are there any questions about this thing? I think we're like 3 minutes over right now. We have like one more problem to go over after this.
No, that makes sense.
So I think the hard thing is probably getting, like, with this one, the new thing that's hard is getting the words out, right? Getting these equations set up. This stuff is all nothing new. This is stuff that we've been doing previously in the previous problems today. Okay. And the last problem. If the number of vehicles per, oh God, I can't read that. What are they doing? They're doing x plus 5, y plus 7. God, it's hard to see these things on there.
Yeah, it's x plus 5 equals y plus 7. X plus 6. No, z plus 6 equals x plus 3. And then y plus 3 equals z plus 4.
Yeah, hopefully if we give you something, you'll be a little more legible than this. I'm not sure how they get in these cars per minute.
Yeah, that diagram has a little, the rates on there.
Hey, this is the X. This is the 5 that they're talking about with that thing. I'm not going to, let's not do, part A is okay. I don't know. I don't like their question, to be honest. I'd rather have you just do part B and C on this thing, if I'm being honest. Like, that is like, it's hard to read this thing.
Amen.
X plus 5.
Equals y plus 7.
Y plus 7. These are the equations they give us. So part B, they say to rewrite these things. So how do we want to rewrite these things?
All the variables on one side.
Yeah. So move that thing over too. Are we together on this? What should this be equal to?
-1.
Well, where are you getting that?
Oh, sorry. I was writing it in my head already. Okay.
Okay.
Yeah. So that's 7.
That should be 7, and then we subtract 5. I did multiple steps.
Okay. Yeah. That's 2. Yeah.
So we have to rearrange these things, right? What is this? Minus x plus z. And this is going to be equal to what? 3 minus 6. So I know I'm doing 2 steps at a time, but hopefully that's not the thing that's confusing you, right? We have to move variables to one side. We have to move things without variables to the other. So if you're doing this in your notes, probably don't do them 2 steps at a time. Do as I say, not as I do, right? Come back in. Okay. But does everyone see how we have to move our variables to one side, constants to the other? These are things that you should be able to do at this point in this class. In order to move the x over, it's got to become negative. We subtract the 6, it's going to be -3. We subtract the z over, it's going to be y minus z. We subtract the 3 over, that'll be 1. So this is our equation. And what's the next step I'm going to do after I have these equations? I have a system of equations I want to solve. How do I solve a system of equations?
You got to convert it to a matrix.
Yeah, that's it. So this is x, y, z. So I have 1. I have a -1. What do I put for z?
0.
0. I heard it. There we go. Don't forget your zeros. We're people too. So 1 minus 1, 0, 2. The next one is just x's and z's. So I have a -1x. What am I putting for my y's?
0.
Don't forget your zeros. Absolutely. -1, 0, 1. This is 1y. This is -1z. And this is 1. And this is 0. So now I'm going to do what?
We have to get them in echelon form.
Uh-huh. So how am I going to do that?
You can plug it into a calculator.
Yep.
You can add row 1 to row 3. You would get rid of one of the ones that way. But wait, then you'd have an extra one.
Did I do this correctly? God, are they giving you? They're not giving you that, are they? Oh God, let's see if I do this.
Did you get all zeros on the bottom line?
Yeah,
I did too.
that's annoying.
I know, right?
It should be numbers for this one, should it not? Or am I just like reading this problem wrong?
I don't know. Maybe because traffic patterns, there's got to be all sorts of variables involved that it might not have a single point for all three roads intersecting, kind of thing.
Yeah, okay.
The timing of stoplights.
But the great thing is that we're in reduced row echelon form, so this will actually be quicker, right? So the wonders of a calculator, you're probably about to see it. 1, 0, -1.
And I hate to do this to you, but I've got to go.
All right, that's fine. Yeah, we're just finishing this up, and then we'll be out of here. We don't have too much longer.
Have a good day.
All right, take care. Thanks. So just finishing this thing up, this is what my calculator is giving me. I'm going to have to do another one of those lines when we see 0 = 0. This should tell you it's infinite. X minus z equal to 3 is what this line is giving me. Y minus z is equal to 1. So I want these z is z. We can always say z is z. So we need to figure these things out a little bit. This, we're going to move the z over. It's going to be what? Z plus 3. This, we're going to move the z over. It should be what? Z plus 1. And the last thing is what? Z is z. So if I'm being honest, this is not my favorite problem, but they assigned it, so I don't know what to tell you. Any questions about this?
Is there ever a time when it's all zeros at the bottom where it won't be z equals z? I don't see a way it couldn't be.
No, so we always do z = z, and z is just like the thing that we hold constant so we can go up and down it, right? For all real numbers, z is what this will say sometimes. So basically what that means is we can go and plug in any number we want into z, and it will keep this sort of pattern happening. And this pattern will produce a line in 3 space. And so there are technically infinite many numbers you can pick for z. And so that's where the infinite solutions are also coming in, right? There's an infinite amount of real numbers. And so we can literally pick any real number out there and fill it in with this pattern, and it will be a point on that line. Any other questions over these things?
I don't think so. Are we going to go over number 43 for 6.3?
Did I skip one?
Well, it's like a whole separate problem from the other ones that we worked through.
Oh, I totally missed that one, huh? Yeah, we can. A sum of 20,000 is invested in 3 mutual funds. In 1 year, the first fund grew by 5%, the second by 7%, and the third by 10%. The total earnings were $1,650. The amount invested in the third fund was 4 times the amount invested in the first fund. Find the amount invested in each fund. So I think we had something very, very similar to this, didn't we not? Where we had like 2 funds.
Yeah, I think it was the problem with the pool pumps.
I think we had this one even before that with 2 variables. So x equals what? The second. A third, right? And so the first thing they tell us is there is what, 20,000 in all 3 of these things. So we want to know how much money is in all 3 of these things. It should look like what? All 3 things, those things are being added.
Yeah, triple pair or triple ordered triple.
Yeah, so we should get 3 different numbers out of this thing, right? So if we want to know if we did 20,000 in all 3 of the accounts, then if we add all 3 accounts, we should get the 20,000, right? That's invested in all 3 of them. If we want to talk about the earnings, how do I talk about the earnings just on my first account? I know it's growing by 5%.
Shoot, hold on. 1.05x?
I think they're just doing the 0.05 because they're just doing the growth because they're going to tell you earnings is what, 1650? I think they're just doing the 0.05x just to do the earnings on it because it's going to be 5% of whatever the heck is in x. The next one is going to be what, 7% of whatever the heck is in y. And then the last one is a what, 10%? Of whatever the heck is in z. And if we add these all up, these are the earnings. So the earnings was what, 1650? So I think you were like completely on the right track, and it does sound like you should do like 1.05. But like this thing was the key indicator in my mind that it wasn't the 1.05. Because if you did 1.05, it would be over 20K, right?
Right, that makes sense.
Yeah, yeah. And then there's like one last tidbit, something about one is 4 times the other. What does it say? The amount invested in the third fund is 4 times the amount invested in the first fund. So I'm going to write this maybe a little bit over here. But this is what z equals what, 4x? Is that what it's saying? Third fund is 4 times the first fund. But that's not going to be a very pretty thing to plug into my calculator. So I'm going to move that 4x over. I have no y's. I have a single z. And this side is 0. We subtract the 4x over. And so now this thing should be set up. But you'll never guess how I'm going to do this thing. 1, 2, 3. 0.05, 0.07, 0.1, 1650. Minus 4, 0, 1, and 0. Okay. Let me go and write the matrix out. 1, 20,000. So that should be like the matrix you plug in. The row reduced echelon form should be spitting you back this thing. And so what does that say? 2,500 in account 1, 7,500 in account 2, and 10,000 in account 3, right? That's what that's saying.
All right. Yeah, makes sense.
So I'm being kind of lazy. Maybe I should write all my words out here, right? But you should be able to give me some English, right? And account 3. Any further questions?
No, I think I'm good.
All right. See you tomorrow, right? That's Friday. Yep.
Thank you.
All right, take care.
Sorry.